happens, the drastic changes will going to happen in the system where you cannot going to meet the healthy nature. But we say the system should be stable enough to operate. So stability is one of the standard parameter for maintaining your synchronization or synchronism operation of a whole system. So normally we call that as a maintenance of synchronism. So synchronization, what exactly the synchronization? Of course, we are generating the power, distributing the power, that and all fine. But connecting to the system, we want to maintain constant frequency, constant voltage, constant current. So if it is go out of the range, then we say the system is not synchronized. Definitely here the problem start with stability system. So synchronous machines of a generation which we use in electrical power, we always require a reliable operation. So that we expect that the synchronous generator should be operate parallelly and to operate for adequate capacity to fulfill the demand. That is a load demand. And whenever your synchronous machines, as we say, it is electrically tied in parallel. So in that case, majorly we need to maintain a constant frequency. So frequency of 50 hertz normally we prefer. Okay. So if everything is fine, you can call that as yes, system is synchronized, or you can say colloquially synchronized system, and you can say in step. So let us assume there is a major disturbance or some upset has happened due to mechanical input or electrical output of a generator. So what it makes, the changes in the movement, that is of a rotation due to changes in the acceleration. So generator may accelerate where other are deaccelerate, means the system, you cannot justify what exactly the operation is going on. We call that as out of step. Means if everything is fine, I call in step. If there is changes, deacceleration or variation in the output, if it is existing in the system, I can call that as a out of step. So in that cases, your rotor angle going to be changed. So you can find wide variations in the rotor movement. So this will going to majorly affect the synchronization of a system coupled with the grid connected. Okay, but we are going with the modern technologies to fulfill this problems which is existing. We're trying to cover up the issues which are happening by using this power system analysis, means determining the fault, which type of fault is existing, how to rectify it. And finally, what we want, our agenda is to reach the stability of the system, maintain the stability of a system. So in normal stable system, let us consider any generator which are connected to the load. So in that cases, you are going to connect particular load. Let us assume 5 generators are there. Out of 5 generators, each will be fixed with some loads. Means you are doing cascading equally. Okay, it's not like one generator will be burdened for a larger scale, because we know that a generating power station, different sources of input we are using it. Let us go for hydro power plant. We are having 10 generator. Of course, winter season, on particularly rainy season, not winter, rainy season, we have abundant input of energy where I can run all the 10 generators. So you're generating a huge energy. But let us go for a summer where I cannot expect the required input of water availability. So I can't run all my 10 generators. So what you do, you'll shut down the generator. So in that cases, you can shut down the system which are not able to carry out. Or else sometimes we people are going for maintenance. You need to check out any problems are existing, or some 6 months once, 1 year once. Normally we people will work on maintenance of each and every devices. So you call that as backout. We call that as a blackout, massive blackout. Or sometimes if the major issues are happens also, for verification, for check out the fault where is it existing, in that possible cases also we go for a massive blackout of a system. So these are the different phenomena where they are going to cause us to verify what is happening, how to analyze the stability system. Okay, we are going to compare different fault analysis, stability analysis with your basic knowledge which you discussed in the last chapter. So I just wanted to go with one of the basic diagram. Just a minute, I'll share. So if you consider, this is a power system stability area. Okay, power system stability area, where it can be divided. This can be divided into major 2 to 3 sections. So I'll just go for 3 parameter. First one, the variation will exist under rotor angle. So rotor angle, then frequency, then voltage stability. Voltage, frequency, rotor angle. Okay. Again in rotor angle, we have two different kind. One is small changes, means small disturbances. Another one is transient stability. Transient stability, you heard this word in your control system. How that's going to affect the system. So transient stability. And these two, small disturbances and transient stability, are contributing for a short term, means they are existing for a shorter period. So we need to analyze this, and that can be cleared within a small amount of a time. But frequency, if there is a variation of frequency stability parameter, again here I have a two cases. Some can be solved within short period, short term, and another one will prolong for a longer period. I can say long term. Okay, so frequency, again two cases, one is short and long. And the last one, voltage stability. So voltage stability, so we'll go with the minimum and maximum. First is small voltage disturbance, then large voltage disturbance. And again here, small and large will contribute two type. Again here, some more can be cleared within small period, another at a longer period. So you have short term and long term. Means some problems can be solved within a fraction of second, but some are requires a much time. Okay, so this is one of the basic diagram of a power system stability analysis, majorly based on rotor angle variation, frequency stability, and the voltage stability. You are assuming it as can be completed within short term, or it will go with a longer term. Okay. So with respect to this, we'll see what exactly the meaning of stability, steady state stability, transient state stability, because most of the times we guys are using this terms. So stability, when used with reference to a power system, is that attribute of the system or a part of the system which enable it to develop restoring forces between the element, therefore equal to or greater than the disturbing forces, so as to restore the state of equilibrium between the elements. So here I think the terms look so technical, but one concept you have to understand. So if any changes are happening, but it should have a restoring capacity to come back to the normal position. So if you are going for any of the balancing activity, so definitely we will try to move forward or backward. It is not so easy to be balanced. But if that possible cases, if you move forward, but you have a capability to come back to the regular position to balance the system. Means in any worst situation here and there, if the movement is happening also, you should have a restoring forces back to the normal position. We call that as a stability of a system. Then steady state stability means maintaining a consistency. So first time here they are stable, fine. Second time also they are giving the same task. If they're done continuously and they're proving themselves, yes, I'm going to be stable forever, then I can call that as a steady state stability. So you can say this is stability of the system under consideration subject to a gradual or relative slow change in the load. Maybe your task performed on the different places, but still you are going to prove that yes, I can achieve the target. Then we can call that as a steady state. It means continuation of a system. If you vary that first place, second place, third place, with a small variations also, your target, your goal is same. So that's we call a steady state stability. With respect to power system, under consideration, which is subject to gradual or relative slow change in the load. Changes, let us assume 5 watt I want. You are keeping 4.5. In that case also it should be balanced. You should not say that is under load. 5.2 volt and 5.2 watt, then again you should not say it as a more than a range. But if small plus or minus ranges are changing happening also, it should be capable of holding at that point. Means try to maintain the equilibrium status for the small change in a system. Then transient state stability. So transient means what happens? Suddenly, okay, the person is concentrating. Suddenly some person come and say, oh, so what will happen? Definitely the fearness or where incapability to hold the system is too tough. But in that large disturbance or a change, very large change of a load, but still you keeping on the same stability, because that is transient, we'll see. This refers to the stability of the system subjected to sudden large disturbances, which is not expected. Large sudden disturbances. So this large disturbances may be brought about by a sudden large change in the load, because see, load is directly affecting the current flow in the system. Every time when you are talking about the machine, we say to write down the ratings, power rating, current rating, voltage rating, because your machines will have a particular ratings of a current particularly. When you calculate, we say what is the highest capacity, 5 amps, 10 amps, 20 amps. Your load will be applied within that range. Let us assume you have applied just 2 amps at the beginning, and suddenly your next step is to take 4 or 5, but you went for 12 volts. What happens is the drastic current will flow through the network, because you are applying a more load. If it is healthy, no issues. But if it is crossing the limit, if you are going out of a scale of a rated current, then definitely it will going to affect the whole output of a system. So fault in the system or loss of the generator in the system, because it was stable, but due to large changes, it's going to create the losses. We call that as a transient state stability. Next is dynamic. So dynamic, of course, dynamic means movement. Static means in one position, constant. So let's see what is the dynamic stability. So this denotes the artificial stability given to a system by the action of automatic control device like fast acting voltage regulators and governors. So everyone has seen regulator. Best example is your fan. Your fan will be controlled by a regulator, right? You can change the speed 1, 2, 3, 4, 5. So here some people wish to change from 1 to 5 directly. They will do. Working means high growth from 0 speed to 1500 directly, but that is not affecting the system, but the artificially it will operate for us sometimes, but it causes a damage due to the high variation. Next is steady state stability limit. Of course, every time I cannot say our system is stable, because there are lots of fault which try to take off the stability. So there is a limit also. It's because when you are considering any of the graph, we start zero from the zero, minimum, maximum, then come back to zero. Or sometimes we say it reaching infinity, it becoming a saturated, means it will not change. So let us assume the curve is increasing like this, not it will go to infinity. Increases, increases, increases. After that, whatever you feed, it will not take. It will be constant single line. So in that cases, we have to specify what is the limit, because once it reaches a destiny, then whatever the changes you do, the remaining is waste of executing the system. So this refers to the maximum flow of power possible through a particular point in the system without loss of stability when the power is increased gradually. It's, let us assume you have a capacity to hold 20 kg bag, and of course trying hard for getting 25 kg bag also. So 25 kg is your the utter last moment of holding a capacity. Okay, so after that, whatever if you give, you're not going to hold it, you're going to leave that, and just your main capacity of 25 you're going to specify. So that will act as a limit, means maximum power, maximum space. Let us assume one room that can accommodate 20 members, so you're forcefully pushing them to get 25. Okay, 25 is also fixed. So after that, the capacity is crossed, you cannot able to move a single step ahead. So that will act as a, without any loss also in the power system. We call that as a steady state limit. Next is transient state stability. So transient state, of course, it is like sudden change happens, and that causes a variation in the system and create loss. Is it? So this refers to the maximum flow of power possible through a particular point in the system without the loss of stability when a sudden disturbances occur. Whenever you heard the term transient, you try to remember sudden changes, sudden disturbances will going to affect your stability of a system. And normal steady state, it is increasing, decreasing cases. Here, when the power is increased gradually, so you're increasing, as I say, capacity 5 to 5, instead of 5, you're going for 10. So in that cases also, your system should be stable enough. But in transient, because of large sudden disturbances will make the change in a system, but still you are maintaining the stability without any losses. We call that as a transient state stability system. An infinite bus. So of course, bus bars, we require to receive the power and transfer the power from one point to another point. A system which is having a constant voltage and a constant frequency, regardless of the load on it, it is called as a infinite bus bar or an infinite bus. Standardly, people will ask this question, what is this bus bar? Because whenever we draw a single line diagram, so everyone is aware of single line diagram, right? So we used to write single line diagram where it is connected to number of bus bars, feeders, transformers and all. So first we write generator, then we used to write some circuit breakers, then isolators, then transformers, and output of transformer again CT, PT, and finally connected to bus bar. Again, you can go for step up, step down, or can be connected to feeder. So this line, thick lines are going to represent bus bar of a system. So that's what they say. Bus bar is called infinite buses, means where you are going to have a constant voltage, constant frequency, higher load, lesser load doesn't going to affect the system. So every time it is going to maintain the constant voltage, constant frequency. We call that as an infinite bus bar system or an infinite bus. Okay, physically it is impossible to have an infinite bus bar system. This is just considered for the purpose of analysis. Okay, practically, of course, we'll have some of the losses, variations in the system, but assumption with respect to the analysis, we can assume this as infinite bus bar. Okay, so then steady state stability. So we are going with derivation parts, number of derivations. Okay, so steady state stability is mainly concerned with determining the maximum power flow, because we say it will going to carry the maximum power. That is the point where it says stabilized. So maximum power we need to find out, right? In the every cases, it may be a transient case or stability case. I need to find out what is the maximum power. So this is steady state stability is concerned with the determining of maximum power flow possible through your power system without loss of a synchronism. Means it should not lose its frequency or a voltage. The paralleling with the system, what you do, they should not go out of control. But within that range itself, you need to determine what is the maximum power. So the formation of a power angle equation plays a vital role in the study of a steady state stability. Means every time we cannot draw pictures. So we are having a standard formula. If somebody asks you what is Ohm's law, we say V is equal to I into R. I don't know how many of you remember the statement, but still we say power equation. P is equals to V into I, V is equals to I into R. Some formulas already remembered, means it is registered in our mind. So similarly here also for the analysis purpose, we are finding the power angle equations.